Resplendent quetzal in the Costa Rican cloud forest of San Gerardo de Dota. Photo by Tyohar Kastiel. A new study suggests that the asteroid-induced mass extinction 66 million years ago that wiped out the dinosaurs, known as the KPG event, led to an acceleration in the rate of genetic evolution among birds, the dinosaurs' only remaining descendants. But these avian survivors look to be about 80% smaller than their pre-extinction relatives. And when the researchers examined an extensive avian family tree, they noticed a clear link between body size and rates of genetic evolution. Small birds evolve much faster than large ones. Size reductions after mass extinctions have occurred in many groups of organisms, a phenomenon dubbed the Lilliput effect by paleontologists, a nod to the classic tale Gulliver's Travels. Cornell Ecology and Evolutionary Biology doctoral student Jacob Berv is co-author of the study, published July 13, 2017 in Systematic Biology. Berv said in a statement there is good evidence that size reductions after mass extinctions may have occurred in many groups of organisms. All of the new evidence we have reviewed is also consistent with a Lilliput effect affecting birds across the KPG mass extinction. Molecular clocks suggest birds are much older than we know from the fossil record, but the discrepancy may be due to an underestimate of the pace of evolution. Image via Gillian Dittner, Cornell University. Study co-author Daniel Field is a fellow at the University of Bath. He said smaller birds tend to have faster metabolic rates and shorter generation times. Our hypothesis is that these important biological characters, which affect the rate of DNA evolution, may have been influenced by the KPG event. The bottom line is that, by speeding up avian genetic evolution, the KPG mass extinction may have substantially altered the rate of the avian molecular clock. Similar processes may have influenced the evolution of many groups across this extinction event, like plants, mammals, and other forms of life. The study suggests that the speedier rate of genetic evolution may have helped stimulate an explosion of avian diversity soon after the KPG extinction event. The researchers jumped into this line of inquiry, they said, because of the long-running rocks and clocks debate. Different studies often report substantial discrepancies between age estimates for groups of organisms implied by the fossil record and estimates generated by molecular clocks. Molecular clocks use the rate at which DNA sequences change to estimate how long ago new species arose, assuming a relatively steady rate of genetic evolution. But if the KPG extinction caused avian molecular clocks to temporarily speed up, the researchers say this could explain at least some of the mismatch. Berv said size reductions across the KPG extinction would be predicted to do exactly that. Snowy owl in flight photographed by Diane McAllister. Image via the Great Backyard Bird Count. The researchers suggest that human activities could trigger an altered pattern of evolution similar to what occurred 66 million years ago. They say that human activity might even be driving a similar Lilliput-like pattern in the modern world, as more and more large animals go extinct because of hunting, habitat destruction, and climate change. Berv said right now, the planet's large animals are being decimated, the big cats, elephants, rhinos, and whales. We need to start thinking about conservation, not just in terms of functional biodiversity loss, but about how our actions will affect the future of evolution itself. Enjoying Earthski so far? Sign up for our free daily newsletter today. Donate to Earthski. Your support means the world to us. Bottom line, a study suggests the extinction event that wiped out the dinosaurs 66 million years ago increased the pace of evolution in birds, their only remaining descendants. Read more from Cornell University.